Hey everybody, welcome to our webinar. I'll start off by giving a bit of an introduction to myself and then we'll jump into the presentation. So my name is Dan Culp. I've been in the CHP industry for about the last 10 years. I started off as a technician and then moved into commissioning. That commissioning has taken me around the world and I've been introduced to a ton of different industries that CHP has been a part of. Recently, I joined the business development team and I take that technical knowledge that I learned to help develop projects for 2G that are going to be a success from day one. Out of all the industries I've been a part of, greenhouse has to be the most interesting, and in my opinion, it would be the best industry for CHP. Let's jump into the presentation and find out why. Rethinking CHP for greenhouses. So a standard greenhouse, the plants are going to grow using natural sunlight. The downside of natural sunlight is on your shoulder seasons, so the spring and the fall, and in the winter, there's less light, so you don't get full production of the plants. To combat this, growers install grow lights so that they can optimize the plant growth and maximize the amount of light the plants get every day of the year. Lighting takes a lot of energy. So how we can offset these energy costs is by installing a CHP system. This is going to lower your overall energy bill and help you to create more efficient energy for your greenhouse. Using a CHP system for electricity allows you to produce your own energy, but it also allows you to have some versatility, whether you're connected to the utility, running completely island, or running parallel, which is a combination of both. In a CHP, we also have a thermal energy output. In a normal building, that thermal energy is going to be consumed when the building needs it. And then if the building is up to temperature, the rest of the thermal energy gets destroyed in a dump radiator. A greenhouse has a really unique system called a buffer tank. It's a large hot water storage tank and it works like a thermal battery. This way, when the CHP produces the electricity for the lights, all the thermal energy that needs to be used in the greenhouse is used, and whatever doesn't need to be used, instead of being destroyed, actually gets captured and stored in your thermal battery to be used later on, maybe at nighttime when the lights are off. This allows you to capture 100% of your utilizable electricity and utilizable thermal energy, creating an extremely efficient system. Due to these really high efficiency numbers, by installing a CHP in your greenhouse, you're actually going to lower your carbon footprint because now your CHP or your energy producing device is far more efficient than a standard electrical grid or a natural gas boiler that you would use to heat the plant. The last unique thing is because the CHP is an internal combustion engine, it has exhaust that comes out the tailpipe. This exhaust has carbon in it, and we can capture that carbon and use it as fertilizer for the plants. So out of the tailpipe, we're going to have carbon monoxide, some C2H4 or excess hydrocarbons from the combustion process, and NOx or nitrogen oxides. These alone are pretty damaging to humans and plants, so we need to clean that up with something that we call an SCR system. The first step is going to go through an oxidization catalyst where we take that CO or carbon monoxide, join it with oxygen and create the CO2. That CO2 is going to be the fertilizer that we use for the plants. Next, the C2H4 or the hydrocarbons get mixed with oxygen and create, again, more CO2 or fertilizer that's directly used for the plants, and H2O, which is just the water molecules that are in everyday air that we breathe. The second step is an SCR system where we spray a urea solution in. When that urea solution mixes with the hot exhaust, it creates ammonia or NH3. The NH3 joined with the NOx is going to output N2, which is standard nitrogen. It's safe to breathe. It's in the air that we breathe right now, and H2O, which is again just water molecules. And then the last step, we put it through an oxidization catalyst where the remaining ammonia and any CO and C2H4 that's left over gets converted to NO, H2O, CO, and CO2. So while we start with some pretty dangerous chemicals in the air, the result after going through an SCR system is a really clean air that can be pumped directly into the greenhouse, consisting of CO2 for fertilizer and harmless nitrogen and H2O. I touched on the resiliency aspect of a CHP. So when we look at a standard system, A greenhouse is powered by the utility. Whenever the lights come on, the utility is present and it powers the greenhouse. The issue is when the utility goes off. Your entire greenhouse shuts down, and if you have a backup generator, it's commonly diesel, which is a really expensive fuel to run on, and you have to start your entire lighting process over again from scratch because everything went black. By installing a CHP, we can actually synchronize the CHP to the utility, match our voltage and our frequency, and couple them together using a synchronizing breaker. Now the greenhouse is powered from both the utility and the CHP. With this setup, the CHP can ramp up power to actually produce all of the electricity that the greenhouse needs, and only a tiny bit coming from the grid or none at all. The advantage to being paralleled with the grid in this scenario is when the grid drops out, the CHP continues to power the greenhouse, and you don't even notice a flicker in your light because they were synchronized together. So now you can ride right through that blackout or brownout that's happening in the grid until the utility comes back. Once the utility comes back, the CHP will recognize it. Our proprietary controller is going to resynchronize the entire building with the utility again, close that utility breaker, and go back to grid parallel, where now the utility and the CHP are both paired together, providing power for your greenhouse. Let's look at expansion. This is happening right now in our area, and we're actually working with a lot of different customers because the current utility doesn't have enough power on the grid to be able to supply the additional expansion that a greenhouse needs. So if you're a greenhouse and you want to add a second greenhouse, whether it's on the same property or another one, you contact the local utility, let them know that you need between 5 and 10 megawatts of additional power for your lighting because you want to optimize your growth year round. The utility says they just don't have the capacity on that grid. While this may limit your expansion, when you find out that you have a solution like a CHP system, you can now provide that highly efficient energy, which can actually be as competitive or even more cost effective than purchasing electricity straight from the grid, and power as many greenhouses as you want. This is going to provide you with unlimited expansion capabilities. Now, the most common fuel we're going to see in this is natural gas. But if natural gas isn't in your area, you're also not limited. 2G CHPs run on a variety of fuels. This can include natural gas, compressed natural gas, renewable natural gas, propane, biogas, and hydrogen. Another thing that CHP systems normally used for is producing power back to the electrical grid. A normal scenario is going to find the CHP running in a gas to power application where you consume the gas, you produce the electricity, and you sell it back to the grid, either full-time or on a demand cycle. With this setup, all the thermal energy gets destroyed in a dump radiator, which means you're only recovering about 50% of your overall energy. In a normal building, you could try to consume that heat in the building, but the problem is that the grid can demand you to run whenever it's required, and your building may not need the heat at that time. The greenhouse with that large buffer tank or thermal battery is the optimal situation for producing power for the electrical grid, because now you can recover 100% of that utilizable heat, store it in your buffer tank, and use it in your greenhouse whenever you require it. So now you get paid to produce electricity, and you get all of the thermal benefit from it, significantly reducing your return on investment, or increasing. We all know that the world is going carbon neutral or carbon negative. And as a grower, you have to be thinking about your future. How can we be as green and efficient at growing our plants as possible? A CHP system is one way to decouple yourself from that standard electrical grid and actually run a green renewable fuel to provide all of the energy for your building. 2G CHPs, we actually have the very first 100% hydrogen CHP system, which means you can run your greenhouse on 100% renewable fuel that's completely carbon-free. Keep in mind, when running on hydrogen, there's no carbon benefit from the exhaust if you need that CO2 fertilizer. So the other option is 100% renewable natural gas. Running on renewable natural gas gives you that carbon neutral fuel that you need. And if you capture the CO2 out of the exhaust through the SCR system, you're actually now a carbon negative grower, which is going to make you extremely competitive in your industry. And if RNG and H2 aren't abundantly present in your area right now, you can install your CHP on 100% natural gas today, and all 2G CHPs are able to run on hydrogen or RNG in the future. This means you can save on energy today, lower your carbon footprint today, and as hydrogen and RNG become available in your area, you can actually go even more efficient in the future. So let's recap what we've talked about so far. A CHP system allows you to produce your own high efficient energy, gives you resiliency if the electrical grid is present or not present, allows for unlimited expansion capabilities, regardless of what utility is present in your area. You can sell the power and capture all of the heat, and you can future-proof your setup to become a carbon neutral or carbon negative grower. When installing any piece of equipment, you want to impact your building as little as possible, both on the construction side and the engineering cost integration. At 2G, our patented CHP container system is a full sound enclosure, and it is a structural container. This structural container means that you can place it anywhere. It can be placed in a building or outside of a building, and it's rated for seismic activity. Whenever you partner with 2G and we put our patented container on your site, all you need to think about is your fuel source, where you're going to get it from, and where you're going to connect it onto the CHP. We provide you the electrical connection points and the thermal connection points. So the last step is just to figure out where to place it. Our containers are fully assembled at factory and tested. This is going to significantly reduce the construction costs, the construction time, and your integration on site. Our products range anywhere from 100 kilowatts up to 2.5 megawatts. This means you can select the exact size CHP you need for your building. Above 2.5 megawatts, we'll pair multiple CHP systems together using our onboard controllers that allow you to expand as much as you need without having to worry about the integration process. We also want to think about the life cycle of the equipment that you're installing. We don't want it to be a burdensome process to install your own power gen equipment. Our CHP systems come fully automated, which means they're plug and play. You install them, set it up, and from commissioning, it'll get programmed to run without the need of an operator input, which means it can turn on when you require the energy and turn off when you don't. You can program it based on your buffer tank levels, so it'll start up when you need more heat and shut down when the buffer tank gets full. And it can integrate directly into your building controller or your lighting controller, which allows you to have a hands-off approach and focus on the growing, which is your main priority. Partnering with 2G, we provide long-term service agreements. This is going to give you a fixed operational costs, both on operating and maintenance, so you can guarantee your payback and have peace of mind that unexpected costs aren't going to come up in the future. We have multiple service locations throughout North America, and all of our technicians are factory trained, and we try to place them as close to our job sites as possible. This way you get to know the technicians in your area, build a personal relationship, and actually have a partnership. So you can trust that the people servicing your equipment care as much about it as you do. Personally, I've been a part of the service team, and I know our technicians are dedicated to keeping those systems running. For CHP systems, manufacturers try to aim for 90% availability or higher if possible. At 2G, we far exceed this. And when we ran our numbers for 2021, we actually had close to 98% availability across our entire fleet. And that's attributed to our manufacturing, which is, I would say, world leading. It's attributed to the relationship between the technicians and the customers and our long-term service contracts. We also have AI technology called Iris that will actually predict when maintenance needs done and notify us ahead of time before a breakdown so we can get to site to keep your equipment running. When you're looking for a provider, you want to make sure you select a provider that has experience in the industry. At 2G, we're going to be your lowest cost, least risk CHP solution. We have over 25 years of experience. We've installed over 7,500 CHP systems located in 55 different countries, and over half of our fleet run on renewable fuel sources already. This includes our 100% hydrogen engines. We have in-house R&D, engineering, and manufacturing. We have unique financing solutions, and I would actually recommend everybody check out Kurt West's webinar on our leasing solutions to find out if that's an option for your business. And we have the best service capabilities in North America. That concludes the presentation today. I think we're going to open up the chat. So if anybody has any questions, feel free to post them there and we'll be happy to answer them. Okay, we have here, I'll stop sharing. One question come in about Blackout Start. So our systems, while they can run grid parallel, they're also fully capable of island mode and Blackout Start, meaning you can install our CHP system at your plant with no utility present. It'll use its own starting batteries to power up its control system and start the engine whenever you require those lights. It'll run completely island mode without the utility and then shut down when you don't need it, ready to Blackout Start again. The smallest system that 2G has is a 100 kilowatt system, and any of our systems can be installed in greenhouses. Sorry, the question is, what's the smallest size engine, and do they collect the CO2? And the answer is yes. So anywhere from 100 kilowatts up to unlimited, if you pair multiple systems. The highest I've personally done is 15 megawatts, and all of our systems have the capability of recovering the CO2. We'll just look for a couple more questions here. Have you made any inroads to the cannabis industry? Many facilities are located in areas with little to no electricity. And I would say yes. For a greenhouse, it doesn't matter if it's a vegetable greenhouse or a cannabis greenhouse, that our systems can power them all. What is the best way to get started with a CHP project at my greenhouse? I would say the best way is to reach out to us after the webinar, and we can connect you with engineering firms that we work with and our local experts at 2G to size the correct equipment for your greenhouse. And from there, start working on the construction and the implementation phase. Are these rich or lean burn engines? So at 2G, we actually provide both rich and lean burn engines. And what we would do is we would work with you to find out your unique needs for your greenhouse, whether that's electricity or heat, and the amount of kilowatts you require to determine if we're going to size it or if we're going to produce it as a rich burn or a lean burn engine. If using hydrogen in the gas mix, what level can you go without any modifications? So our standard CHP system that you install today on 100% natural gas can blend up to 40% hydrogen without needing to make any modifications. If you want to run above 40% hydrogen, it's actually only a small modification to the gas train to be and on the software side to be able to run up to 100% hydrogen. Does Canada provide financial incentives for CHP? For that, I would refer you over to Kurt West, who's our financing manager, and he'd be happy to look into any incentives there is. But I do know right now in Canada, there's a large push for hydrogen and for carbon neutral growing. So those would definitely be two options that we would check out for financial incentives. I had a transmission issue when discussed the buffer tank, but I assume it's hot water storage. Yes, correct. So our CHP systems, they recover the hot water off of the entire engine, as well as an exhaust gas heat exchanger to recover all of the heat from the exhaust. This hot water would then be transferred over to the large buffer storage tank. How much of a challenge has it been to parallel with the utility and or sell back? We found it very challenging for our projects. So that completely depends on your area and the utility. In our area, just a few years ago, the utility actually put out an incentive because they wanted those on-demand systems where they would give an incentive up to 40% to anybody who would install power generation equipment to sell back to the utility. So that is going to be a question for your specific area. If you want to connect with 2G, that can either be myself or Kim, our marketing manager. We can put you in touch with your local sales rep and they can look into those, those kind of questions for your area. Do you get paid for grid power at a special rate? Again, that's specific to each individual area. Is there a kind of green tariff to export electricity to the grid? Yeah, the same answer as the two before is area specific. So that's whatever incentives come from your local government or your local utility provider and what are their incentives to going green. But I would encourage you to reach out to them, let them know that you have an option to produce green power and see if they're interested. Do you use steel or aluminum pistons? Both, depending on the engine configuration. We have a full R&D and manufacturing team where we optimize each engine for the power output. And sometimes that's a higher compression ratio, which would be a steel piston, and other times it's lower compression, and we'd go with the aluminum piston. Do you monitor the exhaust continuously to ensure proper levels of CO2 and other gases? Yes. So anytime where the exhaust is going to be directed directly into a greenhouse, it's continuously monitored because you don't want that exhaust to go in there and cause any kind of a harmful effect on the plants or people. The exhaust system also has a three-way valve that can divert the exhaust directly up and out the roof into a stack if there's any concern about any of the values in the exhaust. And this is going to protect the plants from anything going wrong. Can you send info on potential incentives? Kim will follow up with you, our marketing manager, and she said she'd be happy to share any incentive information that we have. How do you optimize all the operations of the greenhouse? So for this, we could work directly with your lighting controller or your lighting provider and optimize your CHP to work with your lighting controller and your buffer tank, which would also be working directly with you as the customer to make sure that the entire system is optimized for your facility. Do greenhouses utilize absorption chillers? I mean, any system with a CHP could use that heat for an absorption chiller for cooling, but I don't believe that most greenhouses would use that, as a common greenhouse is just going to open up their windows and allow for fresh air draft through for any cooling that they require. Can you provide contact emails for the various topics we discussed so we can follow up? Yes, Kim, our marketing manager, will actually reach out to you guys and send you all the information from what we've discussed and also follow up with any emails to get in contact with the correct person. What is the NOx levels of your CHP engines? So our standard CHP engines range anywhere from 50 to 500 NOx, that's ppm. And then after it goes through our SCR system, we can get down below 10 ppm of NOx. All right, we'll just give it a minute to see if there's any more questions. Okay, there's a question, is it okay to pump 10 ppm of NOx into a greenhouse? So a standard greenhouse, you're either going to bring in compressed CO2 as fertilizer, or you're actually going to capture the fertilizer off of your natural gas boiler and put it into the greenhouse. After the exhaust comes out of our SCR system to go into the greenhouse, it's going to be even cleaner than the exhaust coming out of your standard boiler that's going to pump the fertilizer into the greenhouse. So yes, the NOx levels that come out of the SCR system are definitely acceptable for air that we breathe. Just give another minute for questions. How much of the CO2 can be offset by CHP for plant growth? That's going to depend on how much CO2 you need. So depending on the plants that you grow, there's a different requirement for how much CO2 that they need as fertilizer. And it also is going to depend on your CHP size. So we size our CHP based on your lighting needs or your electricity needs. And the CO2 is just a byproduct that gets captured from that. So for that, you can work with us and our engineers, and we can model out your specific greenhouse and the plants that you grow with your CO2 requirements to find out if 100% of your CO2 can be offset or if it's something closer to 50%. That'll be, yeah, case specific. Okay, that's fantastic. I had a lot of fun presenting today, guys. I'm glad everybody joined us. Thank you for joining. Feel free to reach out to myself. My email is d.culp, that's C-U-L-P, @2-g.com, or reach out to Kim. Oh, there's one more question here. What is the BTU consumption of these units, and how much is the capex of the fuel? Again, that's going to depend on what the CHP system that you install is. But from our return on investment models that we've put out, your CHP system, because of the efficiencies as well, running up close to 90% efficiency, will actually be cheaper to produce your own electricity in most scenarios, depending, of course, on what your electricity price is. But in most scenarios, cheaper to produce your own electricity and heat than it is to buy it from a standard utility company. Okay, thanks for joining, everybody. Have a great day.